Okay, so good morning friends. Today I have brought one model for you, airplane model. It is in front of you, you can see. This is a toy aeroplane of course, and many of us, for our children, we used to purchase it from market. This is a toy, okay. Though it is a toy, but it will make us to understand the concept of an aeroplane very well, okay. So it will be giving us a complete idea. Today I am going to share with you complete idea about this airplane. What are the different components of airplane, and then what are the parts of an airplane, then which part performs which type of function. In general, I am not going to talk about any mathematical concept. So this particular discussion which I am going to have today, it will be purely to give a concept, or you can say some clarification on working of an aircraft for a normal human being, for anybody, though whether he belongs to science background or he belongs to any other background, it doesn't matter. You can say up to 10th standard, 12th standard, everybody is studying science. So some basic knowledge they are having. Okay. So in order to keep themselves updated or to provide some good information to the children who are utilizing this airplane, correct? Okay. You can see like this, it is there, its wheel is also rotating. So we will have a discussion on this particular airplane today. Though I have discussed many times about an airplane and aero engines, I have already posted many of the videos. You can see those videos, but those videos were mainly concentrated for engineering students who are studying engineering. Even this is also applicable for engineering students, because basic concept everybody has to know. Okay, right. So let us start from the beginning, from the nose. So this particular portion is called the nose of the aircraft. Okay, so it is facing the wind. Whenever that aircraft is standing or it is moving, actually its movement should be such that wind should cross over the surface of the aircraft. So wind direction should be opposite to the direction of aircraft. If aircraft is moving in this direction, okay, then the wind direction should be like this. Then only a proper amount of, you can say, lift can be generated. If in the same direction of air in which aircraft is moving, or air is also moving, like suppose air is moving towards you and the aircraft is also moving towards you, then that lift will not be generated. Okay, so it is 100% sure and confirmed that the pilot should know that in which direction the wind is, and these all informations are provided to him through air traffic control. Okay, so near to air traffic control. Air traffic control means the place from where all type of aircraft, its movement, its landing, its takeoff, okay, all communication to the aircraft between pilot and the people who are there in the ground, everything is maintained through air traffic control. So that place is known as air traffic control. And many of you would be knowing that near to a beach you would have seen lighthouse. Okay, so that lighthouse was mainly operated, and till now it is operated in order to guide all ships which are moving in sea. Okay, so that is for the guidance of ships. It is also called an airship. Okay, aircraft is also called as an airship. Okay, because it also move in fluid only. Water is also fluid, air is also fluid, so it is also moving in air. Okay, right. So now that working part, how it works, that I will tell you later. Let us come to know about in all direction about this aircraft component. So see, this is called nose of the aircraft, and mostly you can say in this nose of the aircraft all communication devices, radio communication devices, all radio devices or radar or everything is placed in this front portion. So here one antenna also will be there. Okay, and similarly antenna also will be there on the above the surface or at the bottom of the this fuselage surface, that also will be there. Okay, so it may be having UHF antenna and it may be having VHF antenna. Okay, very high frequency, ultra high frequency, both antennas are there, right? So this is called nose of the aircraft. Now next to the nose, this portion is called, this portion is called cockpit. Okay, this is called cockpit. So cockpit is the place where actually the pilot sits. Now the very first thing you want to know that what actually it is. So it is Airbus A380. Okay, so this model is Airbus A380. So mostly in commercial aircraft we are using Airbus, and we are using even Boeing also. Okay, and in you can say smaller aircrafts, Dornier aircrafts are being used only for carrying a few passengers for chartered flight and all. And in Indian Air Force also they are using Dornier aircraft, and they are using AN-32 and Avro aircraft, that is for transportation purpose. But that AN-32 and Avro aircraft, which is Russian made, that is generally not used in all commercial airplanes. In commercial airplanes we are using Airbus model and Boeing. Okay, Boeing 737, Boeing 787 model, those models are being used. Okay, right. So this is the model which is actually made for Airbus A380. Okay. So now, as I told you, this is the nose and this is the cockpit where the pilot sits. Pilot, co-pilot, they will be there. Okay, right. So pilot and co-pilot are the persons who are having full control over the aircraft. So a pilot, you can say, some people they call that the person who is driving this complete vehicle. Of course, the person who is having complete control, the person who is driving, but we don't call him as driver. Okay, because most of the people, they have made it as general that if anybody is the driver, then he would be sometimes a non-educated or uneducated person, because ground vehicles can be driven by an uneducated person, of course, but an aircraft cannot be driven. It needs a lot of intelligence, it needs a lot of referring of publications, and means you can say manuals and other things. Even the pilot who is sitting in aircraft, many of the emergency situation comes when he has to refer the manufacturer's manual, and then only he has to operate, he has to act in that way. Okay, so simply he is making all the controls and operating it, and simply landing and takeoff is the only you can say mode of driving an airplane like this. It is not there, many things are there. Okay, and it has to move, especially in air. Any type of imbalance, any type of problem, if it is taking place, 100% it is going to be crashed. If it is going to be crashed, nobody will be saved. Okay, nobody will be saved 100%. But on ground, if suppose any problem occurs to the ground vehicle, it will be stopped. Okay, so just beside the road or somewhere it will be stopped in between. At least that type of accident will not be taking place. Accidents are taking place on ground also, that is somewhere intentionally, unintentionally, that is different. But suppose in case any problem comes, that vehicle, ground vehicle, it can comfortably stopped on the ground. But if some problem comes in air, can it be stopped in air anywhere? In air, can it be whether we will be able to land anywhere in stratosphere and troposphere somewhere? No. Okay, it has to come to the ground, and it has to come to ground with full safety. Safety is very much important, gentlemen. Okay, that's why it needs a lot of intelligence to be applied, or you can say a lot of experience especially. Right, so pilot and co-pilot who is sitting in cockpit in this region. Right, then comes to this portion. So this main body of the aircraft, this is completely nose section, and then cockpit, and then from the center you can say this complete body is fuselage. It is called fuselage, where we can say that the passengers will be sitting, or we can keep all the cargo items, our luggages and other things, so that can be kept in fuselage section. Okay, so this is the main body of the aircraft, which is called fuselage. Right, so this is the nose section, main fuselage or main body section, and then at the end it is coming at tail section. Tail section is also different. Okay, so the aircraft is being divided into three parts. One is nose section, another one is main body section or fuselage section, and the third one is tail section. All of them can be separated. Okay, so tail section it is there. Right. Now what are these controls and all it is there, I will come back to you. I have talked about mainly the body of the airplane now. Okay, now coming to this portion, so this is called the wing. Wing we are already knowing, we have seen many birds, they are flying with the help of wings. So aircraft also flies with the help of wings. So the concept of flying has come by seeing birds only, Okay, right. Now this particular wing is especially designed in a different shape is being given, and that shape you can say is actually aerodynamic shape is there, right? So that aerodynamic shape is being given to this wing surface, which is the main lift generating surface. The aircraft without this wing, even if it is moving at very high speed, it will not be lifted up in air until unless these wing surfaces are there, as the birds which has to flap their wing, and then only some lift force is being created, which is making their body to get lifted up. So same way, this aircraft also, it gets lift. Lift is a force. Just a few days earlier I have described about forces of flight. Just you all please see that video. So forces of flight, in that I have discussed about lift, I have discussed about drag, I have discussed about thrust, and I have discussed about that weight. Okay, right. So now this particular surface here, wing surface is there. Okay, so that wing surface is designed especially in a different manner, in a different shape. A special aerodynamic shape is being given to it. Right. Now this wing surface, on the wing engines are being installed. These engines may be different. Also I have discussed in my previous videos, engines used to be different, like turbojet engines are there, turboprop engines are there, turbofan engines are there, then turbo shaft engine is especially for helicopter. So this is not an helicopter, gentlemen. Okay, helicopter in which main rotor will be there at the top and a tail rotor will be there. Maybe sometimes there will be a main rotor and one contra rotating rotor will be there. Then in that case there will not be any separate tail rotor. Okay, so helicopter is different and airplane is different. Helicopter can take off from its own place. It need not to run for a longer distance in order to get lift. But this type of aircraft, it needs to run at a high speed on the runway, and then only this will be getting lifts. Okay, I will tell you that thing. So this is an engine. Generally in transport aircrafts, we are discussing about transport aircrafts, turbofan engines are installed. And if the aircraft is made for taking cargo means for taking loads, luggages, in that case turboprop engines are also there. Turboprop engine means there will be a propeller in front of it. Okay, so that propeller is the main thrust generating surface. Okay, just you see my video for that turboprop. So these are the two engines are installed. Okay, sometimes only one engine also will be installed. Sometimes two engines are there. Another side also two engines are there. So whatever I am discussing about this wing surface, that is applicable for other surface also, other side also. Okay, the very first thing let me tell you that how to tell that which is right side of the airplane and which is left side of the airplane. Like for me, if I am sitting, so I am keeping myself in the position of pilot. So always how to find out the direction, which direction will be right side, which direction will be left side. If you want really to know it, technically you have to keep yourself in the position of pilot. You have to keep yourself in the position of driver. Okay, because if you will be in front of the vehicle like this, okay, your right will be different, your right will be my left, your left will be my right. So in this case confusion will be created. So always right and left Right means starboard. This is called starboard, and left side it is called port. Okay, so this is starboard and port side we have to know only by keeping ourselves viewing from the rear. Keeping ourselves standing at the rear or viewing from the rear, or keeping ourselves in the position of pilot who is facing the nose section of the aircraft. In that case, this right side, this will be, okay, in video for you sometimes it will be showing, so you can see my right hand there. Okay, so this right side will be the starboard, this side will be left, port. It is called port. So port wing, starboard wing. So if anywhere in literature it is written, then you keep yourself in the position of pilot, and then only you view the figure or the plane, and then only you will come to know that which side is starboard side, right side, and which is left side. Okay, so this is the main difference you have to know, right? So the wing surface I have already told you. This is the wing root. Okay, so this wing surface also can be detached separately. So it is attached to the fuselage structure, but it can be detached separately. This is called wing root. This is called wing tip. Okay, wing root, which is attached with the fuselage or main body section, you can see here. So this is the wing root, which is attached with the fuselage. Okay, now this surface is called leading edge. So this leading edge used to be little bit thicker. I am going to discuss about the shape of the wing and design of the wing, so that when I will tell you that how lift force is generated, you will come to know nicely. So this is little bit thicker, and this trailing edge, this is the back side of the edge, this is called trailing edge. So whenever the air is passing over this surface, smoothly it will be going out from the trailing edge surface. So this is called trailing edge, this is called leading edge. Okay, right. In this particular surface, here you can see in the wing surface. Okay, so this particular section will be having flap. Okay, here we do have flap. Okay, so flap is what? This is a movable surface. Flap is movable surface. Downward it can move. So this movable surface, which is flap, it will be used for you can say generating more amount of lift. So during takeoff it is very important. More amount of lift can be generated. So this is one type of lift augmenting device which is called flap, and flap is a movable control surface. Flat surface will be there which will be moving down, and it will be moving only up to the, you can say, edge of this trailing edge of this wing surface. It will not be moving up. Whereas in this section it is called aileron. This aileron can move up, can move down. Okay, right? So this is having more movability, whereas it is having only downward movability, not upward movability. Okay, right. So now you will ask that, sir, what actually it is at the tip? So this is called winglet. So winglet is used in order to reduce the amount of vortices. Vortices means when the air is passing over the skin, over this surface of this wing surface. So what happens? It creates some type of swirling motion, rotatory motion. Okay, so that vortex can be reduced due to use of this winglet. This is called winglet. Okay, now coming to this portion. So this portion you can say it is the main body only, right? And this wing surface used to be hollow, and this wing surface is used to carry fuel. So fuel tank is installed in this wing surface only. Okay, in military aircrafts, even the body of the fuselage is used to carry fuel, because they have to go for long range mission, long range high speed mission. So additional amount of fuel is being carried, you can say, in some type of drop tanks also, and in the main body of the fuselage. So there more number of passengers are not there, only one pilot will be there, or sometimes two pilots will be there, So that's why that full bodies, and even the engine is installed in the body of the fuselage at the back side. Okay, right. Coming to this tail section. So tail section, as I told you, now tail section is having two types of controls. One, this is called vertical stabilizer. This is vertical stabilizer, and this is actually horizontal stabilizer. These two are horizontal stabilizer. Okay, right. I told you about this aileron. So what is the purpose of this aileron? Its purpose is to give the aircraft a rotatory motion like this, a rolling motion. Rolling motion will be created. Okay, to create a rolling motion. So if the aircraft wants to turn like this, so it can have a movement by utilizing this aileron control surface. Okay, so this aileron control surface will give the aircraft a rolling motion. Now, in the tail section, in this horizontal stabilizer, here also movable control surface will be there. These movable control surfaces are called elevator. Elevator. So once this elevator, it is also able to move up and move down. Okay, so downward movability is also there, upward movability is also there. Due to its downward movability, what will happen? The force at this particular tail section will become more, and the aircraft will have nose dive tendency. Okay, so the force will be here, force will be more, so the aircraft will be lifted up and it will have nose dive tendency. So in this case, it will go for landing. So when landing is there, this elevator has to move down. Okay, when this elevator is moving up, the amount of force created on this particular surface will be less, and at the nose section the amount of force will be more, and it will be lifted up like this, so which will be applicable for taking off condition. So if the aircraft is moving and taking off in the air, so this is due to the movement of elevator and flap. Okay, right. So we have discussed about this horizontal stabilizer, in which elevator is there, which is making the aircraft to move up or move down. Similarly, in this vertical stabilizer, we do have stabilizer. These all are called stabilizer because it gives stability to the airplane. Okay, otherwise due to the rotational motion of the engine, this aircraft full body will have a rotatory motion. Okay, it will start rotating at one place like this. Okay, so in order to counteract that, these stabilizers are giving stability. Okay, in this, at the rear surface, this is also called leading edge, this is also called trailing edge. So in the trailing edge, we do have rudder. This also can move left side and right side. Left side, right side, it can move. All these controls are available along with the pilot, and he only moves it, right? Okay, so now due to this movement of rudder, the aircraft at its level flight, this is called level flight, where all the four forces are equal. This is called level flight. Okay, so in this condition, if this rudder is moved, the aircraft will have yawing motion. So this is called yawing motion. Without tilting the airplane, the aircraft will have motion, yawing motion. This is called yawing motion, whereas this was called rolling motion, and this is called nose up, nose down condition. Okay, so nose down, nose up will be controlled by elevator here. Okay, in this case elevator. Okay, rolling to its own axis, you can say horizontal axis, so it is due to the aileron. Yawing motion due to the rudder. Okay, so same way when you are moving towards another side, so this section will be there, then again wing surface will come, and whatever we have discussed another side, same thing it will be there. Okay, duplication, same, all controls are duplicated, right? All controls are duplicated means not you can say okay, elevator is here and here, this side also, this side also, here rudder is there only. Similarly, aileron, both side aileron is there. So what aileron is there? If one aileron is moving up, if one aileron in this section is moving up, the another aileron in this side, it will be moving down. Okay, so why? Now when the aileron moves up this side, the force on this wing surface will become smaller, and when the aileron in this section, it will move down, the force in this section will become greater. So this will create a rolling motion like this. Similarly, vice versa, if the aileron here, it moves down, the force will be more here and it will create a rolling motion in this. Right? So I hope you have understood everything about an airplane now. Now this is called nose undercarriage. This complete assembly on which the wheel is fitted is called undercarriage. So this is nose undercarriage, and these are the two main undercarriage. Okay, two main undercarriage. These two. So these three undercarriages takes complete load of the aircraft, just like our legs, gentlemen. Complete body weight is being taken by our legs, and especially on knee. That's why doctors say that have a control on your weight. If you are not having a control on your weight, your legs and knee will move towards failure. Okay, so that's why some knee pain will be developed, leg pain will be developed due to this overweight condition. So that's why it is a good suggestion from the doctor always, whenever you are going, he used to check your weight first. He wants to find out that as per your height, weight is there or not. If it is not matching as per the ratio, body mass index is not matching, it means somewhere problem has already started in your body. This is the main reason. Here also undercarriages, these three, and these are the two main undercarriages. One nose undercarriage are taking full load of the aircraft, body weight, luggage's weight, passenger's weight, and you can say pilot's weight. Everybody's weight is on the main undercarriage. Okay, right. So I hope all the components you have understood now. Now next point, very important point, that how actually this aircraft is lifted up in this way just by simply running. How this is lifted up? This is everybody wants to know that how it is lifted up. What is the principle behind? So that's why we define an airplane, that airplane is an engineering product or a device which gets airborne or which flies in air without any mechanical support. So a bird is flying in air without any mechanical support. So some mechanism they would be following by flapping their wings. Okay. So similarly, this also airplane, when it runs, so after that what happens, why it is going to the runway, then with full speed it is running and then suddenly it is taking off. Why? So there are some you can say basic physics principles are there. First of all, I will tell you that why this aircraft is moving forward. And for your surprise, gentlemen, I am telling you that in our vehicle, in our two-wheeler, in our four-wheeler, we do have engine, no doubt. The engine is operated by burning fuel. Okay. Power is produced. When the power is produced, that power is transferred from the engine to the wheel, In our motorcycle, the engine is in front. Power is produced, right? Then power from that engine, it is transferred to the rear wheel. How it is transferred? By using chain and sprocket. What is called sprocket? So sprockets are gears. So one small gear will be there in the engine. Another gear, okay, will be there in the wheel. Bigger gear. That is also called a sprocket. And over that one chain runs. So the engine, it produces power. Then you are engaging the gear by pressing the clutch. Once the gear is engaged, it means the engine power will be transferred to the small sprocket, and then small sprocket will start rotating. Over that chain is there. So with that help of chain, the power will be transferred to the rear wheel, and that rear wheel will start rotating, and due to that rotation, your vehicle starts moving forward. So I hope my students, they would be thinking, or children, they would be thinking that engine is available here, engine is producing power, then same way that power would be transferred to this wheel by utilizing some type of gear, by utilizing some type of rope, pulley and other mechanism. So gentlemen, it is no. No dependency or no connection is there between this engine power and the wheel. Wheel is free to rotate. Means free to rotate means brakes and all it is there. But this engine power is not transferred directly to the wheel. Is not transferred directly to the wheel. This is the difference. Then how it moves? Okay. So as I told you, when we discussed about turbojet engine or turboprop engine or turbofan engine, I told you that these engines, air is being taken in and then fuel air mixture is burned inside the combustion chamber, and the exhaust gases are moving out from the rear. Okay, so from these engine points, okay, so high amount of exhaust gases are moving rearward. Okay, this is there, right? Correct? Okay, so the engine which is burning fuel, it makes the gases to move rearward at high velocity in this direction. If it is moving in this direction, as per Newton's third law, for every action there will be an equal and opposite reaction, which we have already experienced. When we have already experienced while swimming. So in swimming, what we do, we move our hand, then pull the water towards us, pull the water backward. In turn, the water is pushing our body forward. Same way, when this high speed exhaust gases, hot gases are moving rearward at high speed with the same speed, with the same force, this aircraft structure is moved forward. Newton's third law. No connection between the wheel and the engine with the help of any type of chain or rope or no connection is there. Due to this force which is being experienced on this engine structure, and this engine structure is attached with this body of the airplane, this full body is pushed, and this is called thrust. This thrust force, which is generated by the engine, is making the aircraft to move forward at high velocity. Once the aircraft is moving forward, high amount of air, okay, so in front air columns are there. When it is occupying the space of air, the air will move rearward. So the speed with which this aircraft is moving forward, the air column also are moving with the same speed over the surface of the fuselage, over the surface of the wing, and it produces some type of drag force also. It produces some type of drag force also. Drag force means which is resisting its movement forward. Its movement which is moving forward, it is resisting. So that resistive force is called drag force. Okay, naturally this thrust force is much more higher than this drag force. That's why this aircraft moves forward. When this aircraft moves forward, okay, so as the amount of air which is passing at certain velocity over this wing surface, okay, over this wing surface. So as I told you that this is called leading edge, this is called trailing edge. The leading edge used to be thicker, trailing edge used to be thinner, thereby creating area difference in area. And as per Bernoulli's principle, the pressure can be changed into velocity, or the velocity can be changed into pressure by changing the area. Okay, so area is in turn related to velocity, pressure. Okay, right. So when this high amount of air which is passing over this surface, over the surface and under the surface used to be little bit flat, whereas over the surface it is called cambered surface. Okay, it is cambered like this. So this is called aerodynamics. Okay, especially designed aerodynamic shape. Aero means air and dynamic means in motion. Okay, so when the air is in motion, this particular surface used to have more camber. Due to this camber, and bottom surface is flat, and area is changed. Due to this change in area, pressure is changing. So it is designed in such a way that pressure or the force on a particular area over the surface is smaller than the pressure which is created at the bottom surface, of the wing. And furthermore, here in order to create more force, as I told you that this particular surface is called flap, which is moved downward while taking off. So it is creating more greater lift force, and thereby this complete aircraft is lifted up. Due to the thrust force, aircraft is moving forward. Okay, due to its movement forward, air is moving at high velocity over the surface and under the surface of this wing. Both side of the surface. This side also, both side of the wing. So once this both side of the wing surface creates force due to the movement of flap, you can say, or more pressure which is created at the bottom edge of the wing, bottom surface of the wing, this full aircraft is getting lifted. Though these tail sections also very little contribute towards the development of lift, and main body also doesn't contribute much more in lift. Lift generating surfaces are mainly these two wing surfaces, gentlemen, these two wing surfaces. And this is the funda behind that why an airplane moves up, how an airplane works. Okay, so the main thing is leading edge, which is thicker, trailing edge, which is thinner. At the top of the surface it is having more cambered. Cambered means just like camel hump is there, no? So that camel hump is one type of camber. So just like camber surface is provided here. Okay, and bottom surface is generally used to be flat due to its design. The pressure underneath the surface, is more than the pressure over the surface. Thereby full body of the airplane is getting lifted up in this way. So that's why we need this aircraft to run on the runway at higher speed. So this particular lift force cannot be created by running the aircraft at slower speed. No. Some certain speed of air is compulsorily required. Then only the lift force which can lift up this airplane can be created. Okay, right. You may tell that, sir, nowadays short takeoff and landing, this type of aircraft is there, vertical takeoff and landing is there, VTOL, okay, STOL. See, those engines, those type of aircrafts actually are utilizing thrust vector control. Thrust vector control. So thrust vector control means from the engine whatever thrust is produced, at present the thrust is in the direction parallel to the axis of the aircraft. Whereas if the thrust direction can be changed towards ground, then it will create a lifting force as per Newton's third law. That lift force will make the aircraft to move upward. So this is called vertical takeoff and landing in most of the MiG-29 aircraft, Sukhoi 30 aircraft, which is available in Indian Air Force, fighter aircraft. These all are fighter aircrafts. So in those type of aircrafts we do have, because they are having a central engine. Okay, they used to have a central body. In that body itself engine is there, so that this exhaust nozzle can be moved. Here that exhaust nozzle will be there, through which that hot exhaust gases are coming backward. Okay, so this can be moved downward, due to which that lift force can be created. Okay, so that thrust direction is changed, and thereby whatever the force is created on the ground, similar amount of force will be created on the body. Okay, so this is actually the funda behind vertical takeoff and landing and short takeoff and landing. So this is there. And as I told about this control, elevator and rudder, so all these are working on the principle of creating a pressure difference on the two sides of the surface, creating a pressure difference. So when elevator is moved downward, so the force on the bottom surface, pressure at the bottom surface will become more than at the top surface. Then it will make this tail surface to move up, thereby automatically this nose surface will go down. Similarly, when this elevator surface is moving up, so bottom surface will be having less pressure, top surface will be having more pressure, due to which this tail surface will move downward and nose will move up. Okay. Similarly, now this rudder surface, once it is moving my rightward, okay, this side, so what will happen? This side the aircraft will be having more pressure. Wherever which side it is moving, that side pressure will become more in comparison to the pressure on the another side, due to which this aircraft, if pressure is more here, so this aircraft will make the aircraft to move in this direction. Okay, so this particular surface will be forced, due to which this nose will have a turning direction. Similarly, aileron also I told you there is to be a pressure difference, and aileron is called differential aileron. Differential aileron. Why differential aileron? Because one aileron is moving up, another aileron is moving down. Okay, one aileron will be moving up, another aileron will move down. So that's why it is called differential aileron. Again, same pressure difference is being created. Okay, now generally pilot is having you can say control column in front of him. Okay, so with that control column, control rod, okay, so the pilot will be controlling elevator and aileron, elevator and aileron. If he is move forward and backward, it means he wants to move elevator, which will make the aircraft to have nose up tendency or nose down tendency. If he is moving the control column sideways, leftward, rightward, then it means he wants to move the aileron surfaces here. He wants to move the aileron surfaces here. This rudder surface he is controlling with the help of his rudder paddle, which is operated by his foot. Okay. So with the rudder paddle he will be able to operate brakes. Okay, he will be able to operate brakes for these wheels, main wheels, and he will be able to operate even rudder pedal also. Okay, so that is designed for both purposes, two purposes. One is for controlling brake and another one is for movement of this rudder. So that's why it is called rudder paddle also. Okay, right. So in this way the aircraft actually works. So there is no connection between this wheel and engine. Only by following physics principle, Newton's third law, whereas for the operation of engine, Newton's first law, Newton's second law, Newton's third law, everything is utilized. Okay, and Bernoulli's principle to produce the lift over this surface. So this is actually a toy aeroplane, but it is suiting us to understand the engineering product in a very nice manner. In place of drawing a figure and I would have explained you, sometimes you would have not understood well. Even I am utilizing this particular airplane to teach my student also when I am teaching them aeronautical engineering subjects. Okay, so right, very nice, thank you, and we will meet again with some another video with some another model. Okay, so bye, thank you very much.